will, okay, so what did I do? What happened? Oh, I hide this. Just a minute. Uh, okay, I am back. All right. Um, okay, let me ask you. I am like 57 years old. Most of you, maybe Kamal and others, are way younger than me. If you remember when I was a student, like in elementary school or secondary school, we used to have booklet for logarithm. If you still remember that, we live these days, booklets for logarithm. And we have booklets for sine, cosine, and whenever we need, we used to go and look into in that booklet. And of course, maybe some of you very young and they are not aware of that, but if you ask your father or your grandfather, I'm sure they will tell you that. Um, but now, maybe if you mention that to young generation, they will start laughing. Oh, we just push, and we find sine and cosine. Okay, so the question is, what's wrong with that? Definitely is nothing wrong with that. In fact, this is, I consider it very advantage, and we all should make use of that technology. There is no need for this booklet anymore because now we can, find the sine and the cosine and logarithm of anything just by calculator. Simple calculator will do that for us. So I call that a very good technology, and I think we all should use that technology. Now, these days, what about math? And in particular, like when you talk about mathematics, many of you see, and maybe during your presentation, if you are in applied math, you will gonna see some pictures or uh, things done by computer. I gotta tell you a story. One time, I was attending a talk and I saw like many pictures and then I asked the speaker, these are made by program. So where is the math? I mean, and he smiled and he started explaining to me how the math involved in these things. Yes, the machine will draw the picture for you and will do great job, but the equation involved to do these pictures, they are very, very high and mathematics complex. I mean, like they have to modify the equation, they have to add parameter to the equation. So there are many ideas, many concepts been done before we see these pictures. But for the outsider, he said, "Oh, whoa, I can do that. These are, no, this is not what's going on. There is a lot of math involved, and many, before we see these nice pictures." Um, and we should not like talk about one without the other. In fact, in my views, these days math and technology work very nicely together because we in the old days we used to spend like maybe weeks or month you know to have some calculation to be simplified and things like that. Now we do it in a minute or a second sometime. So what's wrong with that? This is wonderful. As a mathematician, you should not feel threatened by this kind of technology. And I realized that. And also, I don't have to convince you. Look, we are talking. I am in United Arab Emirates, and you are some of you in Malaysia, some of you in USA, in other countries, in Iran, and we talking. I mean, this is wonderful technology, and that should not be a threat to a mathematician. Because, as I told you, whatever machine you use, machine need ideas. The machine will not tell you so far how to think. The mathematician and other computer scientists, we we have to do a lot of work to make the machine work and give us the outcome that we see in our daily life. Was not just push. No, that's what you see. But that push, they involve a lot of mathematics, very heavy mathematics for us to do. So I thought this is like, something to talk about in this conference to tell you my views about, mathematics and technology. And as a pure mathematician, I work nicely with technology. Of course, there are some technology that I call it bad, maybe because we over doing it like, checking your social media during classroom or something. I don't think this is a good technology. Technology was not made for us to, do that. You can do that outside the class period. So there are many, many, especially I think all of us realize the importance of what we achieved in technology during this hard time. Like I teach online, I give my exam online, I communicate with my student online. So, wow, this is wonderful. This is a very beautiful and, nice technology, and we should all support it and, and encourage it, and definitely is not a threat to what a pure mathematician do or, does. Because as I told you, machine need ideas, concept, and these things usually, ideas and concept, come from a scientist, either computer scientist or a mathematician, to tell the machine how to behave or what to do. Okay? All right, and I thank you for inviting me. And I look at the program. You have many papers and many participants. So I wish you all uh, good luck, and maybe we meet face to face in the future. Thank you very much.
Thank you so much, Prof. If you want to continue, you have at least 5 more minutes,
Oh,
so
oh,
we may enjoy your speech.
okay. Well, I'm gonna show you something I do in the classroom in addition to my talk about uh, uh, technology and math. Like all of us, if you teach calculus one or two, you do, like you come up to things like, I don't know, huh? I want to write some. You want to do this integration, calculus one or two. Definitely, all of you will realize that we need to use what we call integration by parts. This is wonderful. And I think we should teach at the beginning, for the first time, we should teach this method. And in fact, it will not hurt at all to tell the student where this technique came from. Like we tell them, you let one function to be like u and the other one like v prime, and you end up with the formula, I think uv minus vu prime, things like that. Okay, this is wonderful to give them that, and that's what the student like to see. But this is will not take any of us 1 minute to show them where this comes from. It was not magic. I mean, very basic, but I believe whenever we teach that, we should emphasize about the concept because now we solve the problem of calculation. Calculation, we have machines, will do that for us. But the machine, as I told you, will not tell you where this comes from. So this is where really I think where mathematics these days should be about concept, ideas, and methods. Okay, and you do that in calculus 1 or whatever 2, and then you go to higher math like differential, where this thing here, the integration, become not like measure, become a tool. So in some of the courses where uh, like integration or other things in math, as I consider them as tools, I will not do this by, doing, maybe I need to do it twice or three times, integration by parts to come up with the answer for this one. So I always tell them, I mean, since the integration is not like our goal here. We only use it as a tool, and you already learned the method and you know where this method comes from. Nothing wrong to teach them, like, summarizing this method. Like I always tell them, you take a function that easy to integrate and another function uh, easy. I mean, you derive till you reach zero, like this one here I have. E to the x, I can integrate as many times as I want. And this polynomial at one time, so this function I need to integrate and this function I need to derive. Like, you derive it like a 3x squared plus 2, and so on. Keep going. And you integrate e to the x, e to the x, and then instead of doing that two, three, four times, nothing to tell them this. There is an observation how this work. Like, you have start with a plus, minus as a method. Because now I'm teaching a method. I'm not teaching, and some of you, I'm sure you use that. And I call that nothing wrong with that to teach them this method after the student, and you tell them this is not like new math, just summarizing the steps I do in calculus 2. But usually, whenever I do that, I don't teach my student who just started with calculus this method because I want them to comprehend this method, the ideas, the concept. I think I get my point across that even us as a mathematician, my personal views, when we go to upper level, the things we talk like, earlier, we can just use it as a tool. We don't have to be very picky about it and, where this comes from. Or even I don't mind to use a machine to do that if you are in higher level, because this is not our goal. That in higher level, this become a tool, is not an issue or a goal. So this is my personal views how I think of math and technology these days. I think I should stop. Thank you. I think I'm done. You hear me?
Yeah, I hear you.
Okay.
Thank you. Maybe you can summarize your presentation in 2, 3 minutes.
Oh, I still have time. I thought I only have 15 minutes. Okay.
Yeah, but we have some short presentations after you, so
Oh,
maybe
okay.
we can give their time to you.
Oh, all right. Thank you. Well, as I told you, uh, the things I do as not as a researcher, what I do in the classroom whenever I teach higher level course, I teach the other basic by method, like you just do that and you get it. And even I allow you to use technology. And maybe, they said, wow, are you telling us that? No, because, this part in higher level is not the issue. I mean, I'm not going to teach you in higher level how you integrate. So if you find methods that summarize what you did earlier in life, I don't think there is anything wrong with that. And I encourage it. Like another example I do, like when you teach linear algebra. Well, in a classroom or the first time you teach basic linear algebra, you ask them to do all the calculation. And we should do that because they should practice it and learn it. But let's think about it. What's the maximum you can give to a student technology? 3 by 3? I mean, you cannot give them on exam or a quiz 10 by 10 or 9 by 9, you know, being a human being. So we try to explain the concept of linear algebra using small matrices. But when you go to high level, this calculation we did in uh, undergraduate or in very basic is not our goal anymore. It become a tool. In fact, I remember the semester before, I taught advanced linear algebra, and I let my student to go to the math lab and do more, nothing wrong with that, to do more computational things, like matrices 5 by 5, where by hand it will take you forever, or, so why you want to do that when we have this fancy but of course the student only do the computation on that machine, but the machine will not. You always have to tell the machine what to do. It's not like, it will not think for you, like I was doing Jordan form of a matrix, where you have to calculate the minimum polynomial and the characteristic polynomial and so on. In a classroom or by hand, you can explain it on small size of matrices. I mean, you cannot explain that method on like 5 by 5 or 6 by 6 unless you have an easy, you know the polynomial and everything. Yeah, so these things I used to use technology, and my student used to, and I have some colleague, maybe they thought this is weird. I teach advanced linear algebra and I let my student use lab, and I am a pure mathematician. And my argument is that the calculation part is not an issue anymore. If we have something nice, why not? But it is wrong to teach it at the beginning. No, because at the beginning, a student should know the concept, where these come from, how you do it, and then let the machine later on in life or in more advanced course. Again, as I told you, as a pure mathematician, my views of math should be these days about concept, ideas. I was dying. Just give me an idea, give me a concept, you know, because being a human, we solve all these calculation things. Any machine will do that for us anymore. Yeah. Okay, I think that's enough for me.
Okay, thank you, Doctor. We had all enjoyed. your speech
Well,
and hope to meet you in other conferences. And is there any question from Prof. Ayman Badawi? Okay, thank you so much, Prof. We are going now for the next invited speech.
well,
But our
thank you very much. I might leave during because I time difference here. I might go to sleep. I would try to stay for another 10, 15 minutes, and then I apologize because the time difference. I need to sleep.
okay, thank you, Prof. Thanks for your time.
Thank you.
The next presentation.